Have you ever wondered the magic that lies within the everyday batteries that power your devices? It's a question that often goes unanswered, overlooked in the hustle and bustle of our tech-driven world. But today, we're going to change that. Batteries, in their numerous forms, are the unsung heroes of our daily life. From our smartphones to our electric toothbrushes, their silent power is everywhere. Amongst these, one type stands tall: the alkaline battery. These are the batteries that you find in most of your portable devices, and for good reason. They're reliable, they're long-lasting, and they're incredibly efficient. Alkaline batteries truly are the little powerhouses that keep our world running. Their importance in our daily lives can't be overstated. They are the silent partners that make our modern tech-savvy lifestyle possible. Now how about we delve into the fascinating process of how these little powerhouses, the alkaline batteries, are made. What makes up our little powerhouse, the alkaline battery? Let's dive into the components that make this marvel of modern technology work. At its core, an alkaline battery consists of 4 primary ingredients. First up is the outer steel canister. This tough exterior provides the necessary protection and serves as a conductor, facilitating the flow of electricity. Next, we have the manganese dioxide cathode. This crucial component is where the magic happens, as it's responsible for the chemical reactions that produce the electricity we need. Then, we have the potassium hydroxide electrolyte. This alkaline substance allows the flow of electric charge between the cathode and the anode, bridging the gap and enabling the battery to function. Finally, there's the zinc powder anode. This component is the other half of the electrical equation, working hand in hand with the manganese dioxide cathode to produce the battery's power. With these ingredients in hand, we can now begin the assembly of our alkaline battery. The assembly of an alkaline battery is a marvel of modern manufacturing. This meticulous process starts with the preparation of the cathode. The cathode, if you recall, is the positive terminal of the battery. It's composed of a mix of manganese dioxide, graphite, and a touch of potassium hydroxide. This concoction is compressed into a cylindrical shape, forming the heart of our battery. Next comes the separator, an unsung hero in the making of an alkaline battery. This thin piece of material is inserted between the cathode and the anode. It's designed to keep these two components from touching each other, while still allowing ions to pass through. It's a delicate balancing act, one that requires precision and care. Moving on, the anode is added. This is the negative terminal of the battery, made from a zinc powder. The reason for using a powder rather than a solid piece of zinc is that it increases the surface area for chemical reactions, thereby boosting the battery's power output. Once the anode is in place, the battery is sealed. This is a necessary step to prevent any leakage of the materials inside. The sealing also ensures that the battery can withstand the pressure formed during its operation. But we're not done yet. The next step is the addition of the electrolyte. This is a solution of potassium hydroxide, which acts as the medium for the flow of ions between the cathode and anode. The electrolyte is carefully injected into the battery, filling any remaining space. Finally, the battery undergoes a second sealing process. This ensures that the electrolyte stays inside the battery and that the battery remains airtight. It's the final touch on a complex assembly line, and there you have it, the assembly of an alkaline battery. But how does it all work together to produce power? The real magic of an alkaline battery lies in its chemistry. This isn't just a case of mixing ingredients together and hoping for the best. No, it's a precise, calculated interaction of elements that leads to the production of electricity. Let's start with the cathode. This is the positive terminal of the battery, made of a substance called manganese dioxide. The cathode is where the reduction reaction occurs. Simply put, reduction is when an element gains electrons. On the other side, we have the anode, the negative terminal, which is composed of zinc powder. Here, a process called oxidation takes place. Oxidation, in contrast to reduction, is when an element loses electrons. Now you might be wondering, how do these electrons move from one place to another? That's where the electrolyte comes in. The electrolyte in an alkaline battery is a solution of potassium hydroxide. It serves as the medium that allows the flow of electrons from the anode to the cathode. As the battery discharges, the zinc at the anode oxidizes into zinc oxide, releasing electrons in the process. These electrons then travel through the circuit to the cathode, where the manganese dioxide is reduced, absorbing the electrons. This intricate dance of oxidation and reduction, of giving and taking electrons, is the fundamental process that creates the electrical energy we use every day. This intricate chemical dance is what powers your toys, remote controls, and countless other devices. So, what's the takeaway from all this? Well, we've journeyed through the fascinating world of alkaline battery production, and it's clear that there's more to these everyday items than meets the eye. Each battery is a marvel of engineering, a testament to human ingenuity. We've learned that the power within a battery comes from a careful blend of ingredients. Zinc and manganese dioxide, the main active components, are essential in creating the chemical reaction that produces electricity. The potassium hydroxide, or the alkaline, gives the battery its name and is key to the battery's high performance. The assembly process is a delicate dance of precision and accuracy. The components are meticulously arranged in a specific order to ensure efficient energy transfer. The battery's cylindrical shape isn't just for aesthetics, it's crucial for the optimal functioning of the battery. The chemistry behind it all is what truly makes it fascinating. It's a complex process of oxidation and reduction reactions, a beautiful ballet of electrons moving from one place to another, generating the electricity that powers our devices. In essence, each alkaline battery is a tiny powerhouse, a perfect blend of science, technology, and art. It's a testament to how far we've come in understanding and harnessing the power of chemistry. Next time you pop a battery into your device, remember the complex process and chemistry that goes into creating that small but powerful energy source.